So what did you guys think of the exam? Easy?
I don't know, what did we get?
I don't know. And the reason that I just got a set of them today, and there's actually, because of scheduling issues, not of people that aren't here, there's actually 3 people that have to take it on Thursday. So I have, with the way I grade things, and Mark's heard this story before, is I grade a page at a time and I do everybody's at one shot to be consistent. So I've kind of scanned through them and everybody's kind of doing, it looks like everybody's like, okay, right? But I don't have a, here's your grade scenario. So I will have that for next time. But I didn't think it would be really good to go through this. They post that, then they take the exam after they could watch the video. So it didn't quite seem fair to you guys. So. But instead, I got more fun for you. Yeah. Mark, you don't look like you're excited.
Sorry, I'm tired today. Kid woke up at 1, was waiting until like 3:30, so.
This is nothing.
Longer.
This is nothing.
So after he falls asleep, I'm just laying there waiting for him to scream again.
Yeah, yeah,
And,
that's good. And thank you for being first. She's got to watch you for this one too. So. All right, so you get to sign up for your teams for your project, right? And you, the typical team will be a team of 5. Okay, so you need to have 2 distance learning or 2 distance learning members, 2 in-class members, and the other one can be either one of them. If you decide that you don't want that many people on your team, you have a specific size team that you're interested in, you can certainly have a smaller team, but the work doesn't change. So you can certainly do that. I did have a team that wanted to do it, and they were a team of 2. And they put in like 1,000,000 hours, because you're, instead of splitting it 5 ways, you're splitting it 2 ways. But they said they wanted to do it. They got done, but they said they would never do it again. All right, so out here, you get to sign up. Okay, and we'll go through the project in just a minute, right? But the idea is that you get to pick your teams. So the way that it's going to work is basically on Friday is when you get to pick whatever you would want to be with or choose your teams. Okay, and then by Monday, probably sooner than that, but I just want to make sure that in case something comes up as it's been doing, okay, I will randomly assign people that have not signed up. Okay. And okay. All right, so a couple of things on this before we talk about the project itself. Okay. So my expectation, and it should be your expectation as well, is that everyone does the same amount of work on the project. That's why you have a project team, right? So part of the grade, and I will say a significant part of your grade, is going to be determined by the evaluation that you're going to do of your team members, including yourself. So you will be describing what kind of wonderful grade that you would give the other members of your team and yourself. Describe what they did to deserve or receive the non-grade that they should have gotten. And the idea is that they everybody does their fair share, and right, it can't be everybody did the same amount of work, so we all should get A's. That will give everybody else an A and you an F for your evaluation. So part of your grade is your evaluation of the other people on your team. And so, yes,
What if they all did a level work?
that's fine.
You still get an F?
Oh, for you?
Yeah.
Yeah, you would. No, so no, so I have a specific form that you will fill out, and basically it says, what did you do, right? What grade did you get, and what did you do to do it? So there's two components to this, right? It's the work. So did you do the work you were supposed to do, right? So you agree on doing X amount of work. And then what are your behaviors, right? So those are the two things, right? So you could do really great work, right? But your behavior is you get it done at the last minute and nobody gets a chance to look at it when you're supposed to be moving on, right? So the wonderful team lead, as I see you are, Cooper, right? So you are responsible for making sure that the work is distributed. Right? Okay. A behavior that is unacceptable is, because you have distance learning people and they are not necessarily on campus, so you do Hangout or Skype or something, right? And you only attended 4 of the times that we met. So you're there for 4 out of 10, so that's unacceptable. Right? You're working around life, so got it, but right, you're also committing to being a team and doing the work. So the grade that you get, so if everybody did a great job, you say, Kendra got an A+. And why did she get an A+? Because she did all of this work and this was her great behaviors. Mark, on the other hand, didn't do so well. He skipped out on a bunch of meetings. He did his stuff late. We had to redo some stuff. He didn't do some of the things that he should have done, and we're graciously giving him a C when we actually should have given him something less. Right. So you're grading yourself in terms of work and behaviors. You're doing everyone else on your team in terms of work and behaviors. And, right, what this also basically ensures is that, right, because what I find absolutely annoying is everybody gets the same grade when they don't do the same amount of work. That's, to me, is completely unfair. If you have done the work, you should get rewarded for that with a good grade. And if you don't do the work, then you should be called out, and because everybody else had to pick up the slack to do your work. That's unfair to everybody else. Right? So you should be called out for that. Now, there's teams that work really well and there's teams that struggle. But guess what? This is life. So, right? So the team that you have ultimately will be put together, whether your choice or random assignments. So we have about a 50-50 mix of online versus distance learning. So that's why we kind of structured the way it is, right? So from a team lead perspective, so like Cooper, one of the actually first things, even though I'm not listing it, is find out what the skill sets of all the people that you have so that you can decide what it is that you're going to approach, right? Because again, you should be reviewing everybody's work, but that doesn't mean that everybody has to do it, their own version of it and all that kind of stuff, right? So managing that. Right? So you have to, so you have a team number, but you have to come up with a team name, Cooper, so you have to come up with a name for that. And the really great news is I want to be able to see your smiling faces for eternity. So one of the first things that you have to do is you have to come up with a nice team picture. So it could be, individual pictures all in one, or you can get together and take a picture, whatever you want to do, right? But I want to see your smiling faces forever. Right? All right. All right, so let's talk about your project. All right, so you're going to do the Jewelry Biz website, and I have websites in quotes, so this is not that you have to absolutely do web pages, right? So you are making some kind of user interface. And obviously in the background, because this is database class, you have to have databases and be able to do what you need to regarding it, right? So whether you use Microsoft Access and you create a bunch of forms around it, whether you actually make a web page and use SQL Server in the background, right? I am leaving this open to you as a team, right? Because you guys are going to know what the access things that you have in terms of knowledge about or access software-wise, things like that, right? So I don't want to put a specific type on there, right? The only requirement is going to be is ultimately at the end of all this, you have to demo it to me. Okay? And because we have lots of distance learning people that are not in the area, which is why we're still dealing with the exams like we are. The scenario is that not everybody has to participate in the demo, right? But the flip side is the people that are doing the demo, that counts as work, so everybody else should be doing other work too, right? So it's even, okay? Okay, so I have in quotes there the standard website, so main page, contact us, right? So a sequence of basically different web pages or forms or whatever that you can go to from a user perspective. So you have some type of user interface. Okay. Okay. So the user is going to have some type of ability to log on and create an account, right? Sign up for email, so you're going to have to gather data about the customer. So obviously their email address, mailing address, shipping address, billing address, all that kind of stuff. Right? Okay. You're going to have some sort of products, right? So in terms of products, it's everyday jewelry, sets, right, and all this kind of stuff. So, right, and right, you're going to have some sort of cart scenario of putting things into a cart as you create the order, right? So you guys I'm trying to pick something that you guys are all familiar with, so you don't have to really kind of have to think about what the application is, right? So I am sure out of the 5 people on your team, somebody has done online shopping and has used a cart. Right? So that kind of scenario. Right? Okay, so I'm not looking for like this whole monstrous all kind of options and go crazy on things, right? We have a relatively short period of time to do it in, right? So I'm looking for some basic functionality, right? So don't overthink it, right? And right, what I would like to have is, that's why I want to, from the team leads, right, is, right, I am looking for some updates on a kind of weekly basis of updates of how you're doing, right? So are you feeling okay? Have you selected your technology, right? Do you have your, right, any issues, right? Because we want to address those up front. Okay? So again, you're picking your team, you get to pick your technology, you have to have some sort of user interface, you're doing simple processes, right? So again, right, this is not, the way that I like to frame it is this is not a user interface course. This isn't a web design course, right? This is about databases. So you can make the ugliest looking web page you have ever seen, and it's okay. I'm not grading you on the format of how that looks. I'm looking for, does it perform the functionality behind the scenes? Okay. So if you are spending your time as a team trying to make it all nice and pretty, focus on what you need to get done. Okay, everybody okay with that? All right. All right, so there's some reports that I'm looking to be generated, right? So monthly/yearly sales, right? Inventory levels of the products that you have, right? What are the inventory costs, right? So I have items in inventory, I have this many in inventory, it cost me this much, how much do I have on hand, right? So that kind of stuff, okay? Customer list, mailing labels, right? So those are the kinds of things that we're looking for. So, right? Again, don't overthink it. Right? I'm not looking for 8,000 variables or attributes here. Right? But clearly, you have lots of things that are going to be here and relate to each other and things like that. Okay. Right? So you do have to have some sort of shopping cart and checkout process. And you have to calculate some sort of shipping amount based on where the customer is located. Okay, so you get to design this, right? So whether you want to do it by zip code, you want to do it by state, you want to do it by country, right? You can, right? I am trying to make this as flexible as I can, right? Because again, as long as you are doing the actions, I'm okay with that. All right, so the different pages, like I said in quotes, you can go to different locations, pick different things, so I've listed some of those there. Right? And as we said, since we have all this inventory, you have to keep track of that somehow. Right? So we don't have, right, stores per se, but we have, for example, a warehouse that you would have this, or a place that we would be shipping from, right? So again, what I'm looking for is that you are creating the scenario. Okay. All right, so again, this is just an example of things. So we have a pull down list here, right? So I had written up here that, right, items must have some form of drop-down option and or some type of integrity capability. So if you pick something that doesn't have a drop-down list, right, the requirement is that if they enter something, you're using that as your foreign key to go check and see if that's really there. Right? So all I'm saying is you have to have some form of edits on the data entry. And we typically do that using our key structure. Okay. So again, we just have things, example of things to pick from. Right. So the kinds of things that the team lead is going to have to kind of look at and look to structure overall, right? Okay, is your team beyond what I have already outlined at the above? You have to come up as a team with 2 additional things that I have not talked about in here at all. So it's up to you. You guys decide. You need to run it by me for approval, right? Because if it's too easy, I'll say no. If it's too hard, right, I will say you might want to pare it down to something simpler than that. Okay, so this is kind of the check and balance on that. So as a team, you need to come up with 2 additional pieces, and so that should be one of the first things, because obviously everything else depends on that. Okay. All right. So based on the scenario that you ultimately describe, so again, I am looking for you to kind of create a write-up describing what, because each of you teams are going to have a different scenario. So we're looking to have a complete ERD out of what you are building, right? Or what, in this case, the entire enterprise. Right? Okay. We have 3 types of requirements that we talked about. So we have data, functional, and non-functional. Right? So you need to create a document that is going to describe those in some way. Okay? Okay? If you want a template to follow, I have one, but I am not requiring you to do that because, again, someone on your team may have a way that they are familiar with, and they're going to be more efficient at doing that than trying to fit into what I'm layout. And again, this is not a requirements gathering class, but you have to have requirements before you can build something. Right? So, as I said, in the real world, we typically are provided those requirements by the customer. In this case, you are acting at the first part of this project as the customer, and at the end, you are the development team. So you're playing both roles at different points in time. Okay? Right? So you also, as we said, need to determine the technical capabilities. So what technology do you know? What technology do you have access to? Right? So as I said, you may use any implementation strategy or technology that you want, as long as when it comes time that you're able to demo it to me. Okay. Okay. Right. You'll need to determine kind of what your reports are going to look like. You're going to have to create the build DRD since we had the complete one. Right. You're going to have to determine the relational database. If you guys decide that you want to use hierarchy, that's okay too. Right. So don't take this literally. You just have to have some sort of database structure. So your keys, so your right. So again, what I'm looking for in this is that you had a process to follow. So I'm expecting you not to just produce this thing, but I want to understand the process that you went through. So for the databases or tables that you come up with, for example, I am looking for you to say, provide me a document that says, here are all the candidate keys. Here is the one that we selected. Here is the rationale of why we selected it, right? So I want to know that you are doing the pieces that we've talked about in class. Okay? And again, if there's any questions from the what you need to turn in, right, the team lead should just send me an email or talk to me after class or whatever. Okay, we can do that. And then obviously we have to build it and test it, and then you're going to demo it. So, and obviously there's additional tasks in that process to get there, but I wanted to lay out at a high level the kinds of things that you should start thinking about. But it's, again, the team lead's responsibility to ensure that all the tasks are kind of laid out and who's assigned to them. Because again, this is the kind of thing that I'm looking for you to turn back into me in your evaluations. Okay, is, right, Kendra helped identify the additional pieces of functionality. Kendra did the complete ERD. Kendra came up with the write-up on the requirements. Well, wait, where's everybody else on the team, right? So, again, and what I've also found is when people turn that in and they can't describe something, that means that they really didn't participate. So that's my big clue, right? Because if you don't know what other people have worked on, then how can you evaluate it? Okay. Okay. So from a team perspective, there will be a turn in, right? So I will create a group being your teams. You will turn in one set of documents associated with that. Okay, when you do your evaluations, you will upload those individually, and obviously nobody else on the team gets to see that, but clearly they'll know at the end because all of a sudden not everybody gets the same grade, potentially. So again, it's a significant part of your grade because as a team, your expectation and my expectation is everybody does the same amount of work. Not doing the same work, right? And it doesn't match to hours, right? So just because somebody puts in extra hours doesn't mean they're doing the same amount of work. I've gone through that argument before. Okay, so any questions on that?
What are the relevant dates?
Hmm?
What are the relevant dates for this assignment? So are there any interim dates that you have on this, and then what's the final date?
The team lead is going to create a schedule. Because based on your timeline for your team, you may have a different schedule.
April.
If your team decides to do it in April,
So,
I cannot change grades after I submit them after 6 weeks into the next semester. So if you want it in April, you can demo it to me, but I can't do anything about it at that point. So thank you for the suggestion, Mark. Right. So from the end point, so the end point is basically by the time that we take the final exam, right? So final exam day or earlier, you guys are going to set up some time with me to demo it. Yes.
Yours is related, mine is not.
any interim deliverables then, other than, so checking on?
Yeah, so, okay, so again, what did I say the team lead is doing? Every week, they are providing me a list of what, so what I'm looking for from the team lead, and so basically, and I will make it on Tuesdays to make it easy to remember. So by midnight on every Tuesday, the team lead will provide to me a status of where they're at, right? So the status will consist of how you doing, right? So like one sentence, we're doing okay, right? We ran into some problems, but we recovered. We ran into a problem, we're still trying to figure out, right? I mean, it's one sentence. That's what I'm looking for. Right. And then the next piece is, what did you accomplish in the prior week through today? Then, what is the things that you're going to do in the next week, right? So prior week, future week, right? Then any issues and how you're addressing them, and then the final instance is going to be a list of what dates that you have outlined as interim dates. So we know whether things are shifting or not, right? So there, you will upload a document into Canvas on your site that you're going to then just add to every week. So the latest week is always the one that is going to be at the top. So say next Tuesday, which is when the first one would be due, then that would go there, and then so it'd be say page 1 and 2. Okay. So the following week, that becomes page. There's 2 more pages, so the ones that you submitted on Tuesday become page 3 and 4, and the new pages are up front. Right, so the new ones are always at the top, so if you want to scroll down and see what happened for the entire project, you just scroll down and the latest, right? I don't have to scroll down and find the latest thing. I want the latest thing to be at the top. So, again, right? Based on 5 people that you have, some being here, some being there, work, kids, right? Stuff, right? Things shift, right? So I am more interested in getting this thing done based on your schedule, not on my schedule. You know when it's got to be done by, you have an idea of the work of what I'm looking for. Along the way, you get any guidance that you want off of that. You build it based off of the technologies that you have available to you in your way, as opposed to, oh, you have to come to campus to use this technology. Well, that makes no sense. Okay. So, So Cooper, you had a question?
Yes, my question was, is the final exam for this class cumulative?
Is it cumulative?
Yeah, does it, are we tested on the material from today until the end of the semester, or from the beginning of the semester to the end of the semester?
Well, it depends.
Or-
Right. So the general questions on the exam are going to be based off of everything in the second half. But, since it's based off of the stuff that we've already talked about, and there are things that we're going to talk about that will say, well, in the first part of the semester, we talked about this, and this is how it, right? So I cannot say that there won't be some overlap, but the gist of the approach of the questions that will be on the exam are, and the topics will be based off of what we've talked about going forward.
Cool, thank you.
Okay. So, so it's kind of an example, Cooper, just if we talked about relational databases in the last set of slides. Well, that's what the future stuff is going to be talking about, right? So I would say, I'm not going, probably stuff from the last set of slides is probably fair game, but anything before that, I'm not going to go back and go, oh, I talked about this on day one and only on day one, so therefore I'm going to ask it. Now, if I bring it up again, different story. So all I have to do is go through all the slides and pick out all the things I want to talk about again, and we're good. So, does that answer your question as good as I can?
Perfectly, thank
Yeah.
you.
See that, Kendra? All right, so any questions on what I'm looking for here, what I'm expecting out of you? Any thoughts?
In terms of documenting requirements, is going to be kind of similar to what we did in your 200 class?
Yes. I mean, if somebody wanted a template, that's what I would
Okay.
basically give them. So, but again, right, it's a little bit different because you are looking for what is the ultimate requirements that you're going to have from a data perspective. So what data do you need to do report X? And how are you going to get it, right? The SQL that you are going to generate or use a generator to create, right? Right? So what I'm looking for is, right, that it not only works, but you should be able to explain what it's doing and how it works. Right? So when you turn in a final document, right, you're giving me screenshots of stuff that you, right, so it's one, right? Here's screenshots of what we built, here's screenshots of the screen, right? Because, right, when I go through all these demos, they're all gonna kind of like, be churning in my head, and I'm not gonna remember everything. That's why I wanna see your smiling faces on the front of the turn in. I want screenshots of what you've built, right? Right, and you should be able to, in all these things, explain what is going on. Right? Now, I'm not looking for you to write a dissertation and write every last thing, but it's, right? But if it's doing something other than something that is very basic, you should be able to explain it. And we should be able to do what? So what is Mark's favorite word?
Traceability.
That's right. Okay, so, right, what I should see from you, team leads, right, would be, here's a matrix of how we trace to make sure that, yeah, I have something in the data specifications, I have something in the non-functional requirement specification, right? And here's where it is in the, what we built, or what we weren't able to build, whatever the case is. Because again, that's what we have to do in real life, is match it all up. Okay? So, again, you have 5 people, spread the work evenly, and it's not so bad.
When is the submission date?
Pardon me?
When is the submission date? That we should be submitting the,
So the status is going to be weekly on Tuesday,
yeah,
and there's one submission from the team lead,
yeah.
right? And then the final submission date is by the date of the final. I just don't happen to know what that date is offhand.
December 18th.
Okay, so by December 18th, you have to have submitted everything that you are submitting and have done a demo for me. So if you decide as a team you want to do it a week earlier, that's okay, right? You guys are setting the schedule. I'm giving you the final date that you can do it. Right. I mean, if you want to do your demo at starting at 11:30 p.m. on the 18th, I guess we could do that, but I wouldn't recommend it. But again, I'm trying to be as flexible as I can with what you have to do and all of your schedules, because they're all gonna mix and match. All right, anything else? All right, so we have a scenario of there's 2 SQL, so we're talking about SQL today. Okay.
Could you publish that document?
Yes, I'm going to. I don't publish those ahead of time because then everybody like panics because you don't have the background of it. But yes, before I leave tonight, right, Cooper is going to come up here and stare at me while I publish it.
I guarantee it.
You guarantee it, right? So, but no, that's why I don't do it, because then everybody goes, and you don't know, if you don't know the background, then, okay. So it's like the programming class this semester, right? They all got into the lab. I gave them the lab coding assignment, and instead of reading it, they all just panicked and started typing, right? And then you missed this, this, and this, and this, or you misinterpreted this, you left this out, right? And it's because they didn't think about it ahead of time, right? So we have said over and over again, that is the key strategy, and that's why it's important for the team lead to keep people focused, right? Is take your time, get it in order, do it right the first time, and you're gonna spend a lot less time, and then you're gonna have a higher quality product at the end. When you go, we gotta blast through this, and we have certain dates, and we don't adjust dates, we have to stick to this, and everybody just jumps at it, and everybody's going in different directions, right? Trying to tie it all back together, you spend a lot of time that you don't have to spend. So, working as a team, you have to figure out the best way to make it work. All right, so I uploaded the one twice, so that's pretty nice. So I'll delete one of those because they're the same. Right. So we have basic SQL, so that's the slides, and then for a different course that we covered SQL, I have a number of different examples. So that's in the one down here that's actually highlighted right now, which is the SQL doc. So that's kind of a more abbreviated version of it, right? So we'll actually go through both of them, right? But when we get to the SQL doc, we're going to go pretty fast because will be a repeat of a lot of the things that we've already covered. Okay, so Cooper wanted to have some things that make it cumulative, so we talked about SQL before, and what does it stand for? Structured query language. Okay, so now we have something that I can ask as cumulative from the first part of the semester. No. Right, okay, so SQL, right, so, right, it's considered to be one of the major reasons why relational databases are so successful. So what does that mean? Why would we make that statement? And what can you tell me about DB2, Oracle, right, Teradata, stuff like that, right? They're all database systems, Microsoft Access, right? So what can you tell me about all of those? They're relational, and we use SQL against all of those, right? So why is it successful in driving success of relational databases is because it's literally, in almost all instances, it's a standard, right? So, like I said, right, if at the end of this semester, if you got everybody's SQL up on the screen and every team did a different relational database concept, you'd all be able to understand what the SQL meant. Right? Now, there's obviously different ones have little tweaks to them, but in general, all of the basic things. Okay? So it's sort of like spreadsheets, right? Or your text editors, right? How much of the features do you actually use? 2%, 5%, right? Right? So the basic things that we do as database integrators or database designers, database programmers, right? Whatever terminology you want to associate with that, right? We typically do the basic SQL stuff. And that's going to be available in any one of the database management systems. Okay. All right, so we have some wonderful history here, right? So it was initially proposed as a language called Square. That doesn't sound like a really good language. Right? So okay. So I'm not going to ask you about the history, so don't have to think that you have to like remember all this stuff for the exam. Right? Very nice to know that it's there. Right? Okay. But the idea is that it's really an informal or practical rendering of the database with syntax, because ultimately, what do we have to do with our data? What are the two types of languages that we have? Right. So we have the data definition language and we have the data manipulation language, right? And both of those fall under the category of SQL. So it's SQL commands that are going to fall into each of the categories. Because it doesn't matter which database management system that we're dealing with, we have to create databases, we have to destroy databases, we have to be able to insert data into the database, we have to be able to modify it, we have to be able to change it, be able to retrieve it, right? So all of these same things are going to happen from ultimately a database perspective. Okay, so right, the informal things that we had, right? So that, you guys like that matching thing? I think that's going to be a nightmare for me to actually try to figure out where all your lines are going, but that's okay. Right? Okay, so but this is where the informal names came from, right? So right, when we talk about a table, right, as opposed to a relation, it's because SQL, it doesn't say it's a relation, it says it's a table, right? When we talk about the tuple, it's not a tuple, we talk about it in terms of you're retrieving a row of data, right? Okay, and we're dealing with a column, not an attribute. So they mean the same things, right? But we've just gone with, because everybody that's using the SQL types it and talks about it in those terms because that's what the SQL term is associated with that. Okay? So the create statement is the main SQL command for data definition. Right? So which one of those languages does that fall into? DDL, right? Because we are defining the database. Right? Okay, so we have data definition, as we said. We have data manipulation, right? What is transaction control? What is that about?
Is that similar to like concurrency?
Yeah, it's like concurrency, right? It's really great that we have all kind of different names for exactly the same thing, right? So transaction is, oh wait, we can repeat something from last time again to keep Cooper on his toes for the cumulative thing. So what is a unit of work?
It's the set of work that needs to be completed before the entire, that transaction is considered complete, so like an ATM, make sure people's money is.
Right, but it's a, I have to do it all, or I have to make it look like I have done nothing. Right, so you're right, Mark, that it's all of these steps, but I can't only complete part of the steps. Right. So a unit of work is, I have a set of tasks, I'm doing all of those tasks, or I have to have a way to undo the tasks. Okay. So our concurrency is in a sense, right, that we have lots of people going after the same data at the same time. So how do we manage that? Because each one of the transactions is typically considered a unit of work. Okay. So as an example, like my pages, right, are executed somewhere around 225,000 times a day, with the concentration of them between 9 a.m. and 7 p.m. So the likelihood that they are going to potentially conflict with each other, and I have to, the database management system has to arrange for waiting times, right? Make sure we try again if somebody else has some data locked in the process, things like that, right? Something is managing, because what do we know about the data itself? We have to maintain the integrity of that data. I can't partway through update it on Mark. Or I update it and then Mark, who got a copy of it, changes what he wants and writes over the top of mine, and my changes go away, right? That's not going to maintain the integrity of the data. So, right, we have to manage the transactions that are ultimately happening. Okay, what about indexing? You guys are all about speed, right? And what do we know about databases? They are only getting bigger, right? As I like to tell my IT team, and I go have a chat with them, and they go, talk about data. I want all the data for all time. And every time you ask me about, can I purge any data, the answer is no. I want all the data for all time. I don't know when I need it for, but I will probably need it as soon as you delete it. So, no, keep it. They get mad. We don't have strict, I don't care. Okay. But the bigger the process that we have, the longer some things take. Right? So what does it mean when you index something? Right? So you guys, right? We've used indexes since way before computers, when you had what at the back of a textbook? We had an index, right? And you looked up what you wanted and told you where to go to get it, rather than you scanning all the pages to find the one that you want. Right? Well, this is the same thing. I have some keys, and it can be made up of the primary key, or it can be made up of secondary keys. What was the secondary key? Something I'm looking up, which is why we have a index. Okay? So our database management system using this kind of SQL, the input into the process is going to be a SQL command. The database management system is going to have to look and say, what is the best way for the database management system to go out and access this data to satisfy the request? So where do we have the structure of the databases?
Catalog.
The catalog or the metadata, right? Okay, so you get right, so if we go back and look at the slides from before, the query came in and you had the query processor that would go out to the catalog or the metadata and look and say, what is the most effective way for me to go out and retrieve this data, right? Satisfy the request, right? So we have, in most database management systems, we have a process where it kind of looks historically at what were all the accesses that were done, and you can run tools that will come back and say, you know, you're having all of these requests that are really taking a long time, and if you create a new index, you could speed up the process. Right? Right. So you guys have heard of machine learning? Right? So what's machine learning? You look at historical stuff to come up with better ways. So this is like machine learning back before we had machine learning. Right? Database management systems were training on based off of the accesses or the activity that was being asked of it, and it's recording the data about it and then making suggestions on what to change to support that so that it goes faster. Okay, what about security? What kind of things might be associated with that? What don't you want people to have access to?
Social security numbers.
So security numbers, could be addresses, could be your account numbers, right? We have all kind of things, right? So we have ways that we will talk about in here, how you can use the database management system and the SQL that's associated with it to put security in place to ensure that the data that you have is not accessible beyond the people who actually need it. All right, so we have kind of these other things here that we'll get to. So active databases, multimedia, distributed databases, things like that, right, that we can encounter. Okay? So standards, right? So SQL has gone through all kind of standards, right? So they list them all here. And again, I'm not asking you to think about this, but what is the good news about standards and the bad news about standards? Now, this would be a great test question. So what happens if you follow standards?
Bad news is the change.
Well, even worse than that. Right? So let's talk about the good news first. Okay? So if I say, here is the standards I want you to use, it's going to be consistent, right? And if you're doing things consistently and you move around the company and everything follows the same set of standards, you're going to have a better product. Because as you move, you know exactly what to do when you go to the next step. Right? So that's going to make sense. Okay? All right. So that works out pretty well. That's a good thing. So how do we come up with standards? Which is the bad news. You get a bunch of people together in a room, like companies, and you say, we want a standard version of this. Standard version of C++, standard version of SQL, standard version of COBOL, standard version of DB2, whatever it happens to be, right? Okay. And what are they going to do? Because there's the things that they already agree on, and there's all the things that they don't. And what happens with all the things that they don't agree on?
They're exiled. They're forbidden.
What do you mean by that, Cooper?
They are not included in the standard.
Yeah, they're not included because everybody says, that's a really great idea if you change the way that I do it. Because I shouldn't have to change because my way is the best way. Right? So a lot of times standards, when we create those, actually don't have a lot of meaning because it is so watered down to make what's common across everybody that it doesn't fit all the products that are out there. But the flip side is they can all say they are standard edition. Right? So we spend a lot of time on standards, but again, the more disagreement that you have, the more lower level that it moves down to instead of being a true standard that's going to help things. Okay? Right? But if we look back in historically, right, the idea is that we had a process where you kind of evolved through just kind of basic data processes of doing the DDL and DML, right? Then we started to looking into other types of processes, for like we have up here data mining, data warehousing, multimedia, etc. Right? So all of those, right? Okay. So what is the idea of data mining? I'm mining the data to get some insights off of something. Right? So what does that typically mean? I'm looking at a lot of data in lots of different ways, and how often am I doing that same process? Probably not likely to do it again, right? I'm going to run it, I'm going to get my insights off it, I'm going to change what I'm doing to take down the path of what I just learned, and so it's not like my application that I'm running the same thing thousands and thousands of times every day. Right? It's, I search for something, I get some insights, I adjust my search and, right, do different things, right? What about data warehousing? So what's a warehouse? You guys are dealing with warehousing, shipping center, or something in your application you're going to build. So what is it? It's a place where we store stuff, right? Okay, and we put stuff in it and we get stuff out of it. So what's a data warehouse? We put data in and we get data out. But what else can we get out? Not just data, but wow, another repeat. How good is that? See, Cooper, by the end of all this, right, I'm going to cover everything. So, right. Okay. So data warehousing is right. So if you look at a number of companies today, they are actually looking to store all of the data that is generated by the company in a single location. Right? So you want to deal with a hot area in industry today, it is about data strategy and right, data operations. Right? Companies are really struggling with that because of the sheer amount of data that is being generated at a company and how do you manage it. And we don't do a good job of it today. Right? And what happens over time, it's only going to get worse. Right? So the further behind that we get from companies that don't have a good strategy and implementation today or even thinking about how to do it, it's going to make it even harder to get to the point where you can do something with it. So it's that, right? And the companies that I know and deal with data warehousing in, when I've talked to my peers at other companies, they have lots of data warehouses all around that are totally disjoint from each other. And what does that mean if it's disjoint? I have duplicated data or redundant data in all of them because, oh, well, I need it in mine. Well, I need it, right? So instead of having it in one place, I have it in multiple places. And what happens when you have something in multiple places and it changes? You got to remember to change it in all the places. And how do you change it at the same time? Oh, and all the people that worked on and created are now moved on to other parts of the company or retired or something, and you now have no clue that everybody else has gotten this. So data warehousing can get into a big tangle very easily. Okay. Okay. What about multimedia? What's our kind of problems or concerns that we have with multimedia at this point? Sheer volume, right? You think of how many images are out there, how do you search for images, right? Videos, right? Right, and we're not talking the 10-second videos, we're talking the hours and hours of videos, right? Okay, so think about from a standpoint of you, right, so what's out there today in terms of autonomous vehicles? What does it mean? You're running it around, but you have to gather data about every second that this thing is working from all of these sensors all over the car or the truck or whatever, right? And then you have to analyze it, comparing it to the other tests that you've done, right? So a single vehicle is generating multiple terabytes of data every test run. Well, how do you put it all in one place that everybody can access and do what they need to do with it, right? So, right, we think videos and stuff are bad, right? That we're not anywhere close to what the things that we're going to really get in trouble for in trying to manage, right? It's not that it can't be, but you need to put this strategy in place before it's a crisis and you have to then come up with some way to fix it. And again, we're not very good at doing that. Okay, XML. So you guys heard of XML? Right. So what's that stand for? Extensible markup language. Right. So it's basically what? Name value pairs. Right. That you. So again, right. Back. Right. Before XML, everything was a fixed format. Everything was a fixed size. You had everything in a given location, and if you had to change something, you had to literally change the size, and it had to be a fixed location, right? And it got to be this big repetitive process. What about XML? Since it's a name value pair, and you're always just looking at data, you just add another name value pair at the end. Right? So if you look at the features that we have, they created actually an XML data type. Right? So some database management systems allow you to literally store your native XML, and you can search on a name that's in the XML, and it will return the value that's associated with it, regardless of where it is in the string of XML. Right? So that's where when you do things like machine learning, right? So in our statistical models that we've typically done in the past before the machine learning, you did different types of statistical modeling like logistic regression and things like that, right? And you typically did it and where there was, 25, 30, maybe 50 variables that went into your model. Right? Well, in your machine learning models, now you're up to 2,000, 3,000, 5,000 variables, right? I can't keep doing it the way that we used to do business. Right? So we went from having all of these wonderful little columns to we just create one big XML string, and when I want to add more, I just add it in, and I don't have to change the database at all. I change my SQL on how to access it when I access the new things, but I don't have to change the physical database like we used to in the past where everything was in its own individual column. Okay. All right, so, now, if we look down here, SQL3 is the current standard, but it's not fully implemented in any relational database management system. How good is that? It's the standard, but it's not implemented. Why?
Too hard.
It's hard. But why? That would get you 0 points, Cooper. But it's the correct answer, but that would get you 0.
Existing database customers would not be served well with change potentially. So if you were to change the system that.
Yeah, to upgrade, right? So there is so much out there, to upgrade it is going to be a huge cost. And what happens if what you use already works? Do you want to spend a bunch of money and use a bunch of resources to get the same thing out just to go to a upgraded version? Nobody wants to do that. Okay. So they come up with these new ideas and it's really great, but it's like, well, right? So now it's cost versus benefits, so it's all those trade-offs that we typically talk about. Okay. So schema and catalog concepts, right? So the basic standard SQL, there's variations between, as said, the different ones, but in general, they all do the same thing. So again, you think about a programming language, right? What can you do in a programming language? I can declare a variable. I can assign some calculation or some process to get data in and store it into the variable. I have some process that I can do some type of if logic. And I can have a set of nested ifs, or I can use in C++ a switch statement. Oh, but if I use COBOL to do the same thing, it's an evaluate statement. Ooh, right? So the syntax changes, the reserved words change some, but the point I'm trying to make is the concepts behind all of this are still the same. Right? So when we talk about the schema, we very simply, it starts off with having a name. Because what's happened in the catalog? It's stored by name. What a novel concept that is, right? And for that particular name, then we have who's authorized to use it, the description for each element, right? So all the things that the database management system is ultimately going to need to know to be able to process these things, right? So the elements that are going to be in the entire schema for the organization are, we have a set of tables, right? Within that, we have a set of constraints. What are the constraints that we can talk about? Integrity constraints. If I have a foreign key, it has to exist in the other table, otherwise my action that I'm requesting is going to be rejected. Right? I can set a constraint. It has to be in this range of data values. If it's not, reject it, right? So we can do things at the table level, we can do things at the individual attribute or characteristic level, right? Okay, we have this thing called views. Okay, so views fits into typically the category of either efficiencies or security. Okay. So what do we mean by that? Okay. So if we are talking about it in terms of efficiency, right? If I have to run a query that's going to go and look at and bring together 15 or 20 different tables, and it takes 45 minutes to run, I want to run that once, if the data isn't changing, and let people have access to it for the day, and then the next day, I wipe out what I had and I run it again and everybody gets it, right? So behind the scenes, the real data in the real database can change, but I'm more efficient because for what I need to do, I've pulled off only the pieces that I needed, and I only have to process it once. Okay, so from a security aspect, right? So, for example, if I want to make a general view of a database available, I can create a view that is going to basically look like the original table, but I've picked the pieces that aren't going to exist in the view. So it could be things like social security number, account numbers, name and address, right? Right? So the things that I want to keep out of the sight of people that don't need to see it, I can create a view, right? So for us, right, we are audited constantly, and now we have to show that, right, the personal identifiable data, right, that is going to uniquely identify you, right, we have to show that we have it protected from use by anybody other than people who specifically in their job role need to see it. So when I'm audited, right, so when Price Waterhouse comes in, right, I have to show them, here's what we run, here's how it works, right, and they are well versed in all of this, so they know how it all works, right, so. Okay. So the idea is all of these constructs that we have, right, we are going to ultimately have to build, and it has to go into the catalog, because the catalog is ultimately that metadata is managing everything in the way that we process and use it. Okay. And because we love to follow syntax rules, right, your SQL statements will typically end in a semicolon, just like your ring statements. Okay. All right, so in this one I have a create schema, right? So I can literally create schemas, I can create tables, I can create views, right? So create is where you are doing something really technical of creating something. And where are you creating it? You create it and it goes into the schema, right? Into the catalog, right? So in this case, we are creating a schema, right? Okay, based on the authorization that we have, and we've given it a name, right? But the idea is that when I create things, I have a physical creation of it, okay? So the physical actual thing, so it's got to reside somewhere. And then we have the logical schema view, which is in the catalog. So the catalog is going to describe things, give you the characteristics, tell you about how it all lays out, right? I can get any of the data I want out, right? The only thing that the database management system is going to be able to work on is things that are in the metadata. If it doesn't exist in the metadata or the catalog, the database management system doesn't know anything about it. So ultimately we have to do that. Okay. Okay. So our catalog is a name collection of these schemas, right? So whatever you're doing from a schema perspective. And we have the idea that we have catalogs. So what's a cluster of catalogs? What's that kind of, right? So what are file management systems? You guys are used to that, right? When you have, right, your root folder, you have the folders inside the folders, right? So we have a hierarchy of things that we can have related to this. And so our catalogs are very specific to certain areas. And again, for efficiency, right, we can group things. So if my data warehouse And all of the things related to my data warehouse, I might put into one catalog, and Mark's data warehouse, which is in the same overall metadata and the environment, but he may have a different catalog because all of his requests are going there, right? So we organize things into these catalogs to help us improve the processing speed associated with that. Okay. So when we want to specify a new relation or a new table, it's something very simple. Right? So, right, we are going to provide the name of the table that we want to create, and then we have to specify the specific attributes and their data types and any constraints that we want to add into that. Okay? Okay. So we again have a kind of create table command, and we give the name of the table that we want, and then we specify the components in it. Okay. Right? We have what we call the base tables. Okay. So the base tables are relation and its rows, right? So again, they keep flipping back and forth and between the official names and the informal names, right? So our table and its rows are actually created and stored as a file by the database management system, right? So again, physically, in memory, we have to have a location where we are going to store this data. And the data has to be accessible, and it has to be really fast. Okay. Okay. I will always remember the day when we launched one of our wonderful applications. It was really great. It tested out fantastic before our launch. And we launched at 6 o'clock in the morning, and by 10 o'clock in the morning, they were saying, turn it off. And the reason is because the way that we had structured our SQL, it went out to look for something and there was no index. So it literally did what we call a table scan. So it scanned every single row on the table to see what the match was. Well, in our test environment where I had 50,000 records, it went pretty fast. In the production environment where I had 5 million, it took a little longer. And then by 10 o'clock, instead of having the couple of people that were accessing it, now you have tens of thousands of people accessing the same data, and you're waiting your turn is slowed down a lot. Right? So what I'm trying to make is that we have all of this data. We can write SQL and have it do things. And it can work really well or it can work really bad. And it can fool you depending on the environment you're in. So we literally did not know. And then it was, when it happened, it was like, well, that's obvious. Right? Okay, so our relations are created and stored, right? So we store them as a file, right? So the database management system is interacting, right? The bottom line we're trying to get here is the database management system is interacting with the file management system. Because we're storing physical data on a server or on the mainframe someplace or something. Yes?
So what type of files we generate?
Two fair words? It depends. Right? Okay, so for example, right, my indexes are typically going to be made up some sort of tree structure. Right? So I'm creating this structure, but they are all the different records with all the different keys are all managed from an index perspective in a tree. And then once I find the one that I'm looking for, then I have to go to a completely different file format because it has a pointer or an address to go to retrieve the actual data. So my index has a different file format than my data portion. right? If I don't have a index, right, what I could have is a process where I have a hashing function. And what's a hashing function? Right? So a hashing function is where you have a key and you send it through an algorithm to give you a location. Right? So if my key was your name, I would have to translate your name in some way using some formula into a number. And what I have from a file structure standpoint is I have this big area. And I have a starting point, which is location 0. And the hash number that comes up for your name is where I'm going to go to every single time I type in your name, and that's where your data is going to be. So the issue is how do I make all the different locations unique enough to store all the data I need, because I could potentially have a lot of wasted space. But the trade-off is it's really fast. I don't have to do any index, right? So your index, I have to do literally 2 input-output operations. I have to go to the index, I have to search through the index to find where the data is, and then I have to do a second operation to go where the data is and retrieve it. So 2 operations, and it could be on 2 completely different pieces of hardware. Right? Where a hashing function, right, I just calculate the offset location from the beginning of the file and I just go directly there. So it's going to be a way faster, but yours is the only one I can get to. Right? I may not be able to say, well, what is the record before yours or after yours? I can't retrieve them all. Right? So the point I'm trying to make off of that, based off of your question, is it depends. That's why it's critical in this whole process of being able to understand databases and create databases is, well, how is it going to be used? Because again, if my access is always going to be one time, I want to do that kind of hashing function scenario. If I need to traverse through all of the data because I have to process it all in batches, then some sort of indexing thing will probably be able to help me. So there is not a one particular file organization or file structure that is going to work best. It depends on what are you trying to do and how can you spread it. Okay, so again, we have examples where some of your databases or your tables may span multiple servers because you got so much data. Right? So how do I manage getting to the right server, and once I'm on the right server, to the exact location I want on that server, right? So we have those kinds of issues as well. So, did I answer your question? More than you ever wanted to know about it, right? And now I can ask about all that stuff, so thank you. Okay. All right, so, right, so again, we have these files because it's literally data. Okay, the virtual relations or these views, right? So we have a create view statement. So it's just like a create table, except I'm creating a view, right? Okay, and it says it doesn't correspond to any physical file. So that is untrue. Okay, you can have some database management systems will actually, when you create a view, it will physically put it out there. Like we said, if I create a view that I want people to access all day long or for an entire week, guess what? That stuff has to physically exist out there. Okay. So, what they are trying to talk to in this one is, a lot of times views are created one time for your particular use. And then it's going to go away. So you create a view, you use it, it's not in a physical file in terms of, it's not in the database management system or the file management system as a direct file that you physically can go create. It's in a temporary work file that's behind the scenes, the database management system knows there, and when you delete the view, then it frees up that area. So it's in this temporary location. And so what they're trying to say is that in general, your views are going into kind of this temporary memory location, like the way you kind of want to think about is RAM, is an instance like this, but it's not putting it in a RAM, but the concept is there. I put something there, it's there while I use it, but then it goes away. Right? So it's very temporary. All right, so our company relational database schema, so we kind of talked about this one before, is that we had all of, what are all these arrows representing? Right, so these are all of the relationships. Right? So these are the relationships. So the starting point for the arrow, or the base of the arrow, is the foreign key, and the location where the with the arrowhead is what? It's the primary key, but it also represents what? What's the word that begins with a D? The list of all the possible valid values. Domain. See, you guys do remember all that. See how nice that is, right? So in this case, we had ESSN a couple of times, right? We had manager SSN, right? We had supervisor SSN, right? So they are all instances of the SSN primary. Okay, and the project number is hooked to the PNO down there for project number, right? So they put different names there, right? So the point they're trying to make is that they don't have to be called the same name, but you know from a constraint standpoint that there is what we call referential integrity, right? So what that means is what? If I go to insert something into the dependent database, and I have a link set up in the schema between ESSN and the SSN, what is the database management system going to do? It's going to go and validate that what you are trying to insert already exists as a SSN in the employee. If it is not, it is going to reject or not insert the data or the row into the dependent database because there is not a match. Okay, does that make sense? Okay, and what is, to tie this back, what is the works on relation that we have there? It is made up of the employee social security number and project number. So what does that represent?
So works on it is our relationship.
Yeah, that's the relationship. If you go back to the Bill DRD, right? That's saying that an employee works on a project. And we typically create instances like this or tables if it's what type of relationship?
Many to many.
Many to many. So, right, when we get to the point of, in your project, you've created the Bill DRD that is going to drive what databases you are actually going to physically have to create. If you have a relationship that is a many to many and you say you need that relationship, that means you are probably going to build a separate table, just like this one. What happens if it's a one-to-one? You can take the key of one you want to link and put it on the other one. And it doesn't matter which one because it's only one in either direction. So you typically only need to put it in on one side. So you are picking which one that you want to do based off of the work that you are doing. What if it's a one-to-many? The foreign key goes on the many side because then you're only putting one key, which is the one instance of that. Right? So again, your build ERD is the basis for you creating the databases. Right? So again, this is why when you go to most companies or you take any database classes at schools, they concentrate on the build because you're learning about ERDs in a database class. Right? Where they typically don't talk about it is in the requirements gathering. Right? So again, our instance where we talked about it is the complete gives you everything that is possible. Any database that you could imagine that you need. What are the attributes that you have available to you? I want a picture of that to help me figure out what I need to build eventually. But again, most companies don't have that. All right. So again, if we look at the example here, we have employees, we have department, and we have department locations. Right. Okay. And so, what about this department locations? What can you tell me about just looking at this data?
Doesn't look good.
It's what?
There's 3 different 5s. That's crazy.
Why would that be crazy? So if you were to look at this, let's take it one step at a time. Cooper, right? Okay, so you answered, so you get to
Oh,
do this.
sorry. Yeah.
Yeah, too late. Okay. Okay, so we're okay with employee, right? This is a list of all the possible employees. So this is your domain of employees. And what do we know about Social Security number? It is primary key, so therefore it is unique. And it cannot be null, right? You have to have a value. Okay. Right. So you can tell the authors of the book have no concept of what data really is in real life because it is not allowed to have Social Security numbers start with an 8. So when they made up numbers, they put invalid ones in there. So good job, guys. Right. All right. Well, we have all this other data, right? And now, what about this other the Super SSN? What can you tell me about those?
It's a cursive flag.
Right, right. And we have a null in that one. Is that okay? So it's a foreign key. Is that okay?
Appears to be.
It appears to be. Okay. So Kendra, you're looking like you're not agreeing that that's okay.
Yeah, I mean, based off of what we just talked about, if you're to insert something in there, they reference it or cross-reference it with the primary key.
Unless it's a no. Right? So what this is saying is, right, all of these employees except Mr. Borg down here has a supervisor. Right? So, good old James down here doesn't have a supervisor, just off doing his thing. He's an employee, but he doesn't have a supervisor, so that's okay. Now, what if Super SSN was a primary key? Then you could not. So foreign keys, if there is a value that's non-null, it has to be in the domain. If it doesn't exist, which is okay, as Mark pointed out, then it has to be null. Okay, does that make sense? Yeah. All right, so we're okay with that one. So let's go to department. Mark Cooper, is that one okay?
Yeah.
Yeah, you think so? Okay. So how many departments do we have?
Oh, no.
You have three. You have three departments. We're not talking locations, we're talking departments. Right? So what is department in this case? It is the domain of all the possible valid values for a department. So if I come in and say department number 2, the answer is no. Doesn't exist. But if I want 1, 4, or 5, it's okay. All right. Now, let's get back to the last one over here. So, what do you think this one is, Cooper?
I think it's,
First off, they named it poorly, but that's okay.
I think, it's a weird relation.
It is not a weird relation.
I would have just put delocation on the department table. I don't know why they did that.
Well, let's analyze that. So, thank you, Cooper. I didn't even pay you for this. Okay, so let's start off with just saying locations. So let's drop the G number column and drop department out of the top one, and let's just say locations. Okay? Okay. So the weird relationship that you're talking about, that isn't so weird, is saying that departments exist in locations. Right? Okay. And what do we know? A single department can have multiple locations. Okay. And a location can have multiple departments. Right? That doesn't sound so weird. Right? So this is another example of a many-to-many, where they didn't show you off to the side that locations was separate. Okay? So this is what we do just to mess with people. Okay? Is if I'm going to create this, I want it to run efficiently. And if I was to, even though it's true from a standpoint of a build ERD, I'm going to have department made up of the department number, the department name, who the manager is, and their start date. And I'm going to have a location that's going to be made up of Houston, Stafford, Bel Air, Sugar Land. And I have a many-to-many relationship. And what do we say you do when you have a many-to-many relationship that you have to build? You take the keys of both and create a new instance. Right? Okay. So what does that mean for this though? It means, right, if I was to literally say locations, right, I would have eliminated one line over here, and so I'd basically be duplicating the locations column here all by itself. And do you really want to do that? Not really, right? So again, right, they don't come up and say why they do these things, but this is all about efficiency in processing the data. Because what happens if I want to get a list of all the locations? I should be able to, with my SQL, go against this table, strip off all the duplicates in the location column, and I get all my original list. So the data's there. I can still get what I want, but I don't have to have a separate table to process against to do it. I wish it would explain that, but they don't. But I wanted to make sure you understood it rather than just say, oh, here's some tables out there and they look really nice. Okay, so is there any questions on that?
Yeah, so the new instance, is that new instance the relationship that you're basically?
What do you mean the new?
So you said when you have a many-to-many relationship, that you take the keys from each, and you make a new instance.
Yes.
That new instance
It's considered a table.
it's considered a table
Yes.
in a ERD, would that be drawn as,
On the ERD, it's a relation,
okay,
right? It's the diamond,
okay.
right?
Um,
And you,
so-
but right, so again, you have created the build ERD, you have two entities, you have the relationship, and it's many to many from a cardinality standpoint.
Yep.
That's what you are still building,
Yep.
right? It just happens to be, if I'm going to have the apartment, right? I have a location, and I have this relationship, and I said, from an efficiency standpoint, it doesn't make sense to have them three tables. I can narrow it down to two,
Okay.
and still be able to get the same exact data I need, but my process, and my way my database management system is going to work more effectively.
And the DBMS will handle that in some cases, correct? So if you're creating that relationship.
Well, you are creating it. You have to tell the database management system in its catalog, this is what you're doing,
Right.
right? And so what you said is that I'm not creating this thing called locations. So even though it's on my diagram, I don't need to because I'm doing this instead.
Okay.
And so if I was to just look at this mini world here, in the schema world that's in the catalog or the metadata, I only have 3 tables.
Right.
But on my build ERD, I would see 4 things that I would be saying I'm building. Does that make sense?
Yeah.
Okay.
Never mind, got it.
That is the best question, Cooper, that when students answer it before they even ask, so I don't even have to worry about it. I appreciate that. But what was it so that we all know what you were thinking?
My question is, without the answer, my question is, department number and department location are both specified as primary keys, and there are duplicates in both fields.
Mm-hmm.
So what's up with that?
What type of key is it?
Well, that's the answer. That's
It's
why I
a
said go ahead.
composite key, right? So because it's a composite key, It's the combination of all of the attributes together that has to be unique, not individual pieces. So the fact that I have 5 department numbers, like Bel Air, Sugarland, and Houston, in combination with the 5, make the combinations unique. So if I tried to come in and insert a 5 Bel Air again, it would reject it because it already exists. But if I put in 5 and Detroit, it would let me, and I would have a new location that we'd identify. But it's hooked to the department number 5.
Is it physically possible to just have a foreign key relationship and have department location be an attribute?
So, ask that again?
Is it possible to just have a foreign key with D number and then leave location as like a plain text attribute instead of making them a composite key? Understanding, of course, that every table should have a primary key.
Well, every table should have one. The issue that you get to in your scenario that you're describing is, so if I have a location, so the location as the primary key, right?
I would.
No,
yeah, sure, yeah.
okay, go with me on this and see if I answer your question, right? So I pick Houston, right? And now you said, I'm going to have some non-key attributes to represent the departments. Right? So how many do I need for Houston?
2.
2. Okay. How many do I need for Bel Air?
1.
1. Okay. Now, what if I add another Houston department?
Still 1 for Bel Air.
So, right. But what I'm saying is that how do you know how many you need? If I make 3 non-key attributes, what happens when I need a 4th one? Or a 5th one? Right? So if I have Houston and I have 2 attributes, and in the first one I have a 1, and in the second one I have a 5, and now I say, well, I'm going to have department 4 in there as well, and I don't have that attribute, I have to add a new attribute. And then what happens when I have not 3, but 4? Right? I have to keep changing the database to do that. So keeping it as primary keys like this, right, composite key, I just add another row. I don't have to change the underlying structure of the table to get different combinations. And if I want to, I can query the table using my SQL to find that 1, 4, and 5 are all related to Houston. So I can just query the table to tell me that. I don't have to go to a Houston row and pick off the non-key attributes to tell me that. I can get the same result. So the bottom line on all of that is that in the end, you want your database tables to be as stable and change as little as possible. Because what happens every time I change it?
Chance for error.
Transfer error, but I now have to add a new column. I have to populate, right? So I have to run something to change that table because I want to add a new column. Now I have to run something that is going to load data into that, and it's all going to start off to be null because I'm just going to say populate the whole table. Then I have to go in and update just the ones I need, right? So there's all these steps instead of just saying insert a for Houston and be done.
So, don't you have that problem with delocation if you don't specify the domain somewhere else in that other table? So by lobbing off that other entity,
No, so D number is a domain, and you know that that's linked over to the department.
but delocation currently, at least on the slide, isn't.
Right, delocation is not, right? What you're saying is that, in this case, delocation is your domain. You are allowing duplicates in it. And if I want to know what the true domain is, I need to strip them off, right? Strip the duplicates. And I can potentially, if I need to do that, what way did we describe earlier today that you could do that? Starts with a V, ends with a W. View. Right? So I could create that. So in kind of temporary memory, I can have the exact domain, no duplicates, access it and do what I want with it. Right? But I only need to create that when I need it. Right? Right. So again, kind of what I think is kind of behind the scenes with what Cooper has kind of laid out for us on all this, so thank you, Cooper, right, is right, in the database world, we end up jumping all around to all these different tables and all these relations, and what happens every time that you have to jump around to do stuff? It takes time. And, right, when you are on a web page and you want a list of the different products that you can buy, how long do you want to wait for all the information to be gathered to display it to you? How much? 0, right? 0 is too long, right? I want instantaneous. I want it to already know what I'm thinking and have it on the screen before I even have to hit anything. Right? That's what we'd like. Right? But again, the more data that we have, the longer these things take, the more tables that we have to go to get the data that we want, the longer it takes to do everything. Right? So we have trade-offs that we ultimately make when we actually design or create what we are looking to do. Okay. All right, so we have some other ones here, right? So we have the works on, right? So again, what do we know about that? All the things in the ESSN are all going to be on the employee, and all of the P&Os over there are going to be on the project for the project number. And again, we can have multiples of those, right? Because it's a many-to-many. So when we have a many-to-many, it's a composite key made up of the primary keys of the two domains that we are linking together in the many-to-many. Okay, now, what can you tell me about the dependent? It's a, what kind of primary key? Composite. Okay. But only part of it is a referential integrity. Right? So the ESSN is matched to what? The employee, right? So why do we have to have dependent name as part of the composite. Because you can have multiple dependents, right? But this is a, what type of relationship? One to many, right? So one employee can have many dependents, and what did we say if we had a one to many? Where did the foreign key relationship go? On the many side, because there's only one instance. So that gets us back to the idea that Cooper brought up, so thank you for bringing it up, so we can talk about it again. Okay, so back here on employee, I could say, here's all the dependents that we have. So I can make columns out here that are not attributable, right? Or I can make them foreign keys, right? Okay, but how many dependents are you going to put on somebody? What's the max?
Many as they have.
Yeah, but if I'm designing this database and I say, okay, Cooper, you want dependents listed for an employee, how many should I put out there?
I don't know.
5, 10,
One.
1?
Be strict, it's fair. I see where you're going.
Yeah, no, right, so, what, the example I like to use on this is, one of my cousins actually, does a lot of work with, disabled, so he actually is, basically made them dependents of his, and between him and his family, they have 15. I can't imagine like doing it because they all have disabilities, right? So this is his life, but he's got 15. So the groups that he had to deal with all had to change their databases that had that kind of structure because nobody had that many. They're like, well, we can't record them all. We'll type it on some form and we'll remember to look it up. And he's like, no, right? You have to record everybody, right? So, and actually, I had that instance here at school because they only had room for 2 undergraduate degrees for people. Of course, I got 3. And they're like, well, we'll remember to type it on your transcript anytime that you request one. Really? I don't think so. So, the wonderful IT department here on campus didn't like me because I had to actually change all the programs to flip it around. So, good thing a lot of them were in the same class as I was. All right, so just because we don't know, it's easier to do it on the many side because then you know, like we have here, that we have one as the foreign key being the social security number, and we have the dependent name as a combination that's going to uniquely identify it, right? Okay. But again, this scenario says that you can't have 2 dependents with the same name. All right. So this is if we're going to define it. So if we look at this, we have, this is the SQL that you would have to actually create the tables, right? So we have create table employee, and we're going to have the different variables, so F name, M in it, right? So go down those, right? Okay, and we have the different types associated with that, right? So varchar 15 says what? I can have up to 15 characters, right? If it's just a char, it's a single character, right? If it's a decimal, right, I have 10 places and 2 after decimal, right? So we have different things, right? Character 9 is always going to be specifically 9, right? Okay. So, right, so the idea is that we have a whole group of data types. So just like you had programming languages, you had data types. In the database world, we have data types. Okay? And what is the third column? That's your constraint, right? So what about the name field? So first and last name? It's not null, meaning what? It is required that it's filled in with some data. You try to put null in there, it's going to say no. Okay. And we have not null on social security number. So what's that telling you? You have to have a value for that. Down at the bottom, we have primary key is SSN. So what's that telling you? Not only does it have to have a value filled in, but it has to be unique. Okay. All right. So what about department? Okay. So now if we look down for manager start date, we have a date data type. Okay. So what happens if you try to put something that is not a date into it? Right. Not gonna let you do it. Okay. Okay. So we have down here that we have a primary key, which is the D number. So what's that mean? It's not null and it's unique. Okay. Okay, so department name can't be null, department number can't be null, and the manager SSN cannot be null. Right? And okay, so now we have down here, we have this thing called unique, and it's dname. What's that mean? So that was a kind of a candidate key, right? Because it's not null and needs to be unique. We did not select it as a primary key. And why would we not? Because it's way easier to keep track of a primary key that's an integer rather than 15 characters or up to 15 characters. Okay. But what is this forcing? This is forcing it to be not only not null, but it has to have a unique name compared to everything else. So even though it's not a primary key, it's not null and unique. Everybody okay with that? Okay, and what's this bottom one? Foreign key, manager SSN, references, employee SSN. What's a foreign key? I'm going to another table and I'm verifying the referential integrity of this piece of data. So if I'm inserting something into the manager SSN, the database management system, before it will put that data out there, is going to go to the employee table, is going to do a search on the SSN field. If it matches a entry in there, is going to allow the row to be put in as long as all the other constraints are met. If it doesn't find it, it will not allow you to insert the row. Okay, so what about department locations down here? Okay, so again, this is we have a primary key, but we list two things. So what's that mean? This is the order that the primary key is looked at. D number is first, D location is second. And only the D number is going to be actually looked up as a foreign key. Everybody okay? Right. So, okay, now what about, let's go to works on. So what are you going to tell me about that one? I have two foreign keys that make up the primary key, right? So again, this goes back to, if we look at the Build ERD, the primary keys of employee and project, because the many to many are going to be brought together, composite primary key, and they are both foreign keys because they have to go back to the employee and to the project to find the values. And if it doesn't match, it's going to not allow it to be inserted. So, again, all the rest of this is the same stuff that we have already talked about. Okay. All right. So some foreign keys may cause some errors, right? So we may have some circular references, or they refer to a table that hasn't yet been created, right? So we have ways to actually say, don't do the referential integrity, even though you can. Okay. So what's the problem with that? If you turn it off,
Gotta remember to turn it back on.
right? And what else? While it's off, you can put in bad data. Right? You are putting in a risk that you are potentially going to put in bad data around that. All right? So the basic data types all kind of match back to the data types that you are used to from programming, right? So we have numeric, right? So we have integer numbers, so integer, int, and small int, right? So again, just different sizes of those. We have our real numbers, float or real or double, right? So you guys are used to that from your C++ and other kinds of things. We have fixed length, character strings, so again, these both represent the same thing, right? Different ways to do that. Okay, varying length, so we give maximums, right, associated with that. So, okay, we have bits. So, unlike a lot of languages, we actually can store things in a single bit. But what happens when you store something in a single bit? It's still going to allocate at least 8, so you don't really gain anything. Okay? But we can do that. Okay? And we can have a number of bits. So you can say, I want 18 bits. I want 35 bits. Right? So we'll adjust it. We have Boolean type, right? And if we have true, false, or null. And what does null mean again? It's got some value, because there's some value in there, but I don't know what it is. Okay? Or it actually doesn't exist at all. No. Okay? Right? So date type has 10 positions, so it's year, month, and day in the form of year, month, and day. Okay? And most database management systems not only have a date, but they have a date time. So you would have the actual time, and it would go typically into the milliseconds. Okay. And we have the little note down there that we have multiple mapping functions available in our database management systems to change the formats. Why? Because we don't always display them in that way. Right? So you can change it to the US format or the European format. You can change it to a Julian date, right? There's all kind of different formats that you can use associated with that. Okay. Right? So as we said, we have the timestamp, right, which is a combination of date and time, right? And we can have a time zone qualifier, so typically a lot of times it's just listed as universal time, right, or Greenwich time, but we can put it to a specific time, right, so it will automatically adjust for you. Okay. We have what's called the interval data type, so it specifies a relative value that can be used to increment or decrement the value of a date time, right? So how much do you want to adjust it by? So, right, what do we know about different time zones? In general, they are the same amount of time apart, so I can adjust it. Okay. Right. So again, we can do casting, and if you remember from your programming days what casting is, you're taking a certain data type and you are converting it into another one temporarily to look at. So we can use date, time, timestamp, interval, data types. We can convert them all to strings, and then we can compare. Okay. All right, so not to be confused with all the other domains, we now have another domain. Right? So Cooper would always want me to say, give me all the definitions of domain that we've ever talked about in our entire lifetime in this class. Okay. So domain is a name used with a attribute specification. So we're creating the attribute. Makes it easier to change the data type for a domain that is used by numerous attributes. It improves your schema readability, so we have create domain, so security type as a character 9. Right? So what that's basically allowing you to do is then I can use as a type kind of as a generic name, right? And then I'll just pick up these attributes. Right? So this is really great. We see it in all the textbook stuff. I have seen one instance of this in all the database systems that I have ever worked on. So it exists, but okay. User-defined types are supported for object-oriented applications, right? So we have right a create type. So we've actually had to create some. You just don't know what the data type is going to be. It can change based on who is sending us the data. So, right, we don't necessarily want to treat it as a character. We don't want to treat it as a string. I may want to treat it as a number, right? There's all different formats that I want to ultimately be able to work with on it. So, we create it as a UFO type. Unidentifiable formatted object.
Rorschach test for your abbreviations,
Huh?
right? There's a Rorschach
Yeah.
test for abbreviations.
Yeah. Yeah. Right. All right, so constraints, right? So we already saw some constraints that we put, right? So our relational model has 3 basic types that are supported in SQL. Right? So we have a key constraint, so primary key cannot be duplicated, right? So, right? What else can that be? Can't be null, right? So I wish they would state the whole thing, right? So a key constraint, primary key value cannot be duplicated. It cannot be null, right? Okay. What do we say about a secondary key? It can be null, it can be duplicated, right? It's just something that you are searching at. Okay, and entity integrity constraint. Primary key cannot be null, right? So they kind of put them in separate lines, but we always just say, guess what? Primary key, not null, not duplicated. Okay? And the referential integrity constraints are the foreign key, right? As we said, it can be a primary key or no. Right. So, other things that we can do is we can default a value of an attribute. Okay, so right, if you don't get a value in, it will automatically, so if I create a row and I'm inserting data into that row and I don't have a value for that particular attribute, it will take the default value of that and put it in. Should you do that? Say no. Right? You always want to be in control of what it's doing. You may not know that it's going to do this. You want to know and have control over what data goes into your database. Because ultimately you are responsible for it. So therefore, any place that I've ever had a default value, I always still put it in, and even if it's the default value that I'm putting in, I want to know what I'm putting in and valid. Okay. Okay. So, as we said, null is not permitted. You put not null, right? Okay. And we have a check clause. So if we look at this one, we have, right? D number is what? It's a data type of an integer. It cannot be null. And I want to check if the number is between 1 and 20. Okay. So, the database management system is doing this check for you. So, what's the good news? The database management system is doing this check for you. What's the bad news? You forget that it's doing it for you, and you now need a 21. And all of a sudden, your stuff is getting rejected. And you go, oh, I forgot I did that. Why'd we do that? Right? So, I've seen multiple instances where, again, when people create the stuff, they know it's there, right? But people move, right? You don't make changes, right? So probably out of my 550 some databases, we have changed probably 15 of those in the last 2 years. Right? We don't change them very often. Okay, as we talked about, we have the primary key clause, so we identify it as a primary key, right? So again, the way that the book has laid this out, so in our examples, where in these slides where they just listed them all, the SQL, right? The different format than what they have here. So again, you have, just like in programming, you have multiple ways that you can do the exact same statement. Okay, so as I said, unique specifies that your secondary key is called candidate keys in the relational model, right? So it's unique, okay? And what does unique imply? It implies not null. Right? Kind of. Okay. So, what should your rule be? Don't make any assumptions of what could possibly be assumed. If you want it to be unique and you want it to be not null, state it. It doesn't hurt anything. Okay? Again, if I take the same DDL command and I take it between different database management systems, sometimes I get different results. Okay? So, and it's always been on something we didn't specify. Because everybody likes, well, it does it automatically, so why would I spend the time typing it in and all that kind of stuff. All right, so our foreign key, right? So reject our update on a violation, right? So again, if it doesn't find the value, it doesn't let you do it. Okay? Right? It's have a referential triggered action clause, right? So we can have it, if it violates it, we still insert it, but we don't insert that data value, but we set it to be a null value instead. Okay. We can not set it to null, but I can set it to a default value, and we will talk about Cascade later. But basically what Cascade does is it says, take this action and then take a series of following actions that, because I'm cascading tasks to other tables to do things. Okay. Right? So the action taken by the database manager for set null or set default is the same on delete and on updates, right? Okay. And so the idea is that ultimately what happens with data? I insert data, I update the data, and I delete the data. And I'm going to have different actions that can take place or constraints on that if I do those. So what's an example of a problem? I go back to the employee table and I delete an employee. What's the problem? If that employee has that social security number is in all these other tables, right? So unless all the other tables are cleaned up, the database management system has to come back and say, I will not let you delete this because there is referential references to this. So it's not blindly going to do what you tell it. But the good news is it's there for a reason. It is making sure that you maintain the integrity of your data. Because that's what you need. Okay. All right, so we have some constraints so we can name it. And, right, so the idea here is instead of just generically creating all these, I want names so I can reference them. Okay. So again, they have this, but I've probably seen this only a couple of times. All right, so we will pick up on this slide, but if you just take a look at it, right, we have the constraints at the top, we have the primary key, we have things that we are doing with it, right? So we'll kind of walk through this next time as our starting point, right? But you see that this is getting now pretty complex when we actually go to do all this stuff. So our first ones were pretty easy, but now we are headed down the, let's make it more complicated and fun. So with that, what's happening this week? Put your name out there, find your team. If you don't, I will assign you to a team. Okay. You need a team leader identified because on Tuesday you should be telling me that you have met, that you have started thinking about your extra piece of functionality, that you should be thinking about the technologies that you're going to use, so what's your communication plan? Are you going to meet? Are you going to meet on campus? Are you going to be on Skype? Are you going to do both? Right, what kind of things that you are doing. Right. So in your sign up, right, please include your email. So Cooper, if you'd go back and add that, right, on yours. Right, and the reason for that is obviously, right, other people that are signing up need to, you have to create some sort of list of, right, distribution list. So thank you. Have a great night.